This chapter you will deploy safely with 3 mechanisms that work together: CA, canaries, feature flags, and a rollback plan. You'll also build the canary then expand deployment gate so you stop treating releases like a hope ampre event. Canary then expand deployment gate, the 3 controls you need before you ship. A canary is a controlled slice of traffic or runs that you send to the new agent B. Have your first, while the rest keeps using the old behavior. You pick the slice size based on your risk and your ability to observe. The key is that the canary gets real load and real inputs, not a fake test dataset that never hits edge cases. A feature flag is a runtime switch that decides which behavior to run. You flip it with out redeploying code, and you can target by environment, tenant, route, or even a run attribute like workflow version. Feature flags let you turn a bad behavior off fast, even if the deployment already landed. A rollback plan is the pre-written sequence of actions that restores the last known good behavior quickly. You don't figure it out live. You define what to revert, what to. Copyright P2R Collective 2026-56 Disable, and how to confirm the system recovered before you declare the incident over. Ask yourself one question before you touch a release pipeline: if the new behavior starts failing, how fast can you stop it, and how small does the blast radius stay while you do? Breaking down canaries, flags, and rollback plans into something you can run. Here's the canary then expand deployment gate, step by step. You will wire these controls so you can deploy, observe, expand, or stop without heroics. 1. Start with a clean version behavior boundary. You need a single place where the system chooses behavior. Don't spread the deci shown across 5 workflows and 3 helper services. Make one decision point that selects old or new agent configuration. In an N8N setup, that usually means your workflow reads a run parameter or environment setting and routes to the correct prompt/tool configuration. 2. Add a feature flag that can disable the new behavior instantly. Create a flag like agent_behavior_new_ enabled. Your workflow checks it at run time, then selects either the new or old behavior. You want the flag to live somewhere you can change quickly: environment variables, a config service, or your orchestration layer, and you want the workflow to log the decision every run. If you can't prove which behavior ran, you can't debug fast. 3. Define canary routing that limits blast radius by design. You route only a small fraction of runs to the new behavior. Do not base it on first come, first served unless you can predict load. Instead, pick a deterministic rule so you can reproduce behavior during debugging. Common approaches: route by tenant ID hash so a tenant stays consistent during the rollout. Route by workflow input attribute, like a specific account type. Route by run ID modulo a number, for example, only runs where run_ID %10 equals 0 inch. Deterministic routing matters because it keeps your observations stable while you monitor. Copyright P2R Collective 2026-57-4. Instrument the canary with the metrics that tell you stop or expand. You need a small set of signals you can check without building dashboards from scratch. Pick signals that map directly to agent failure modes. Tool call failures, for example, HTTP errors from your downstream APIs. Agent output VA. Lidation failures, for example, schema mismatch or missing required fields. Retry rate spikes, your workflow retries more than normal. Latency jumps, your queue waits longer or the agent runs take longer. Ethan's mistake was not having if stop condition. He watched errors and logs, but he didn't have a trigger that told him to halt and roll back. Your gate must include stop conditions. 5. Use a rollback plan that flips behavior back, not one that rebuilds hope. Your rollback should do 2 things. Disable the feature flag for the new behavior. Keep the old behavior intact and reachable. If your deployment also changed underlying code paths, your rollback must cover that too. Pre-plan whether you revert the container image, redeploy the previous version, or simply switch the flag back. The fastest path usually disables the flag first. Then you decide whether you need a redeploy. 6. Expand only after the canary proves stability under real constraints. You expand in controlled steps, increase canary coverage, or add more tenants to the new behavior. The point isn't to find the perfect test window. The point is to keep the system inside a safety envelope while you learn. If you want a quick mental model, canary tells you, is it safe enough to keep going? Feature flags tell you, can you stop immediately, and rollback tells you, can you restore a known good state fast? Making it work in a production N8N agent workflow with outguessing. Let's ground this in a real operational pattern. You run an N8N workflow that calls Claude to generate an action plan, then calls your internal APIs as tools. You also copyright P2R Collective 2026-58 force rate limits so the agent doesn't hammer downstream services. You plan to ship a change to the prompt template and tool parameter logic. You will implement the gate like this, with concrete checks you can do during the rollout. 1. Create 2 behavior configurations you can switch between. Keep old and new prompt plus tool parameter rules available side by side. Do not edit the existing behavior in place. Your workflow should reference behavior_version. Values like v_old and v_new. 2. Add runtime feature flag evaluation inside the N8N workflow. Add an early step that reads agent_behavior_new_ enabled. Then set a field like selected_behavior_version based on the flag. Log both fields. The flag value. The selected behavior version. Expected outcome: when something breaks, you can filter logs by selected_behavior_version and stop guessing. 3. Implement deterministic canary routing. Add a step that decides whether the run goes to the canary. For example, compute route_bucket equals run_id %10. Route canary when route_bucket equals 0. If you don't have a good run_id, use a stable identifier you already have, like tenant ID. Expected outcome: you see consistent behavior for the same tenant during observation. 4. Combine canary routing with the feature flag. The decision rule should look like this in plain terms. If feature flag is off, always use old behavior. If feature flag is on, use canary routing to decide old versus new. Expected outcome: you can disable the new behavior instantly even if the canary rule says this run should go new. 5. Add stop conditions and wire them to your rollout operator. During the rollout window, you watch the canary only, not the entire system. Stop conditions should be simple and actionable. For example, copyright P2R Collective 2026-59 more than a small number of tool call failures in the canary window. Output validation fails that exceed your normal baseline. Your rate limit handler starts triggering more often than usual. Expected outcome: when a stop condition trips, you flip the feature flag off and stop expansion. 6. Run a rollback drill before the real release. You practice the exact sequence Ethan didn't have the first time. Flip the feature flag off. Confirm canary traffic now uses old behavior, log check. Confirm error rate and latency normalize. Expected outcome: you can execute under stress without fumbling. 7. Expand in increments that your monitoring can handle. Increase canary coverage stepwise. If your first step routes 1 out of 10 runs, your next step might route 2 out of 10, then 5 out of 10. Keep each step long enough to see tool call behavior and rate limit interactions, not just agent responded once. Expected outcome: you learn whether the new behavior breaks downstream tools or Triggers rate limit spirals. Ask yourself, what part of this gate can fail if the system gets weird? Your answer should usually include the decision point and the stop trigger. Lessons learned from real rollout failures. What kills you? During expansion. You don't need fancy. You need discipline. Here are hard-won insights from rollouts. That went sideways, stated as takeaways you can see ROI into your next deployment. A rollout fails when you can't prove which behavior ran. If you don't log the feature flag decision and the selected behavior version for every run, you lose hours. You end up debating whether the new prompt or the old tool logic caused the failure. Add those logs before you ship. Then you can slice errors by selected_behavior_version and move fast. Copyright P2R Collective 2026-60. You should treat rate limit handling as part of the rollout surface, not a separate concern. A prompt change that increases tool call frequency can push you into retry storms. Your canary might look fine at first, then downstream latency rises, retries stack up, and the agent keeps working on bad conditions. Your stop conditions must include rate limit handler behavior and tool call error patterns, not just agent return text. Your rollback plan must work even if the new deployment partially succeeded. If you only plan to redeploy an older container, you can waste time when the pipeline is stuck or the new code partially deployed. Your rollback should start by disabling the feature flag so new runs stop using the risky behavior immediately. Then you decide whether you need a full code rollback. Key actions recap: you build the decision boundary, you log